there are two types of lyric. One that gives you the Z as the major, and the other one gives you an E as the major, which is why I said I need to make sure you understand this. I'll start with the shortcuts, and then we'll do the mechanism.
Okay.
So again, this is me, a mouse biting while blowing your finger, so that you don't get scared too soon. But this is one of the easiest ones. So if someone gives you, let's say someone gives you this versus someone gives you this. Modify this to ET. There's a difference. That's what you're doing here. Let me see, where was I? Where is this thing? Here. Carbon density weight. Okay, good. Yeah. So usually the reagent is gonna be this PPH3 thing. Sometimes it can be written as this, but it's the same thing. It's just resonance. We need what we call the nucleophile is the yield. We'll do the mechanism shortly.
Okay.
Let me know when you're ready. I know you like shortcuts because they've been helping you.
Yeah, when I was doing the mechanism stuff today, I was just like, okay, PAD, had step. Like,
Yeah.
what that I could figure it out.
Yeah. So we're going to lose this. This is always lost. I've done this reaction so many times. I don't want to exaggerate and say a million times, but so many times. And usually this is gonna be lost as triphenylphosphine oxide, always. So how I usually circle, so far we've done, I've been circling stuff saying you're losing HCl, you're losing CO2, you're losing water, mostly in our shortcuts. In this case, you're losing that always, which is why if you do that shortcut, you're always good to go.
Okay.
Yeah. So I'll assume that my yield is blue. See if I can find my blue pen. Okay, I don't like the font. So I'll assume my yield is blue. So the connection is gonna just happen where the double bond is. Assume you're just connecting the double bonds basically. However, you don't want it to be E. Anytime the yield is unstabilized, we call this unstabilized yield because there's no electron drawing group.
Okay.
Unstabilized, not Y-lead, yield
Okay.
gives Z as the major. This right here is Z because you can see the high priorities are on the same side, low priorities are on the same side.
Okay. Okay.
Just to remind you, these are low priorities. You're cutting the double bond into two based on atomic number, like what you do with RNS. That's two. This carbon right here is one. This carbon is one. The hydrogen is two. So you have 2, 2, 1, 1, same side. That's C's, or I think let's call it Z. It's the same implication, C's or Z.
Okay.
So that shortcut is done. Here, if you look closely, this lone pair can do resonance to the carbonyl. See that?
Yeah.
So this yielded is resonance stabilized. So when you're dealing with stable yields, they should give E as the major. In the test, you'll be asked for the major. It's the ester factor that makes the E to be the major here. There's computation stuff to prove this, but anyway, I don't think you're interested in going that deep. You already have a lot. Your plate is full. You already have a lot to do.
Yeah.
And you can tell that's an E because if you carry it across, which is why I tell students you don't want to forget organic one. You'll be in trouble. They are opposite.
And then how do I know when I have a stable
You see exactly what I did here.
I should draw the resonance structure of them
To see them, or you'll have an electron drawing group, or this is conjugated, you can see. So if you have double bond, if they don't give you the lone pair and the plus charge, the negative and the plus charge, no, it's conjugated.
Okay.
There's a double bond here, there's a double bond there. There's possibility of resonance within the yielded. Additional resonance, both of them have resonance, but the one with the carbonyl has additional resonance. Basically, most likely you'll have an ester, if not an ester, a C double bond N, something of the sort, or NO2. Basically, electron withdrawing group, I should say,
Okay.
that have double bonds, yeah.
Okay.
Are you good?
Yeah.
So you need to know the difference between stabilized and unstabilized yielded. Stabilized yielded, you'll have that electron drawing group or a carbonyl group, or we should say an extra double bond that will cause extra resonance stabilization. Unstabilized is most likely just alkyl group. And unstabilized will always be alkyl group, I should say. Here, you have an alkyl group. So if you see alkyl group, you better give me a Z. If you see ester, you better give me an E. Okay, now the ball is passed back to you. Don't run away. You need to give me the answers. Sometimes you get neither. Let me put it like this so you can see that can give you neither. Alright, go for it. I'll be back. I have to clean my glass lens. Ooh. You got it?
Yeah, I got the first
Oh, you're
one.
stuck.
I think I
Yes.
got the first one.
Okay, let me draw what I think it is. Um, so pretend this is red. Yield is a nucleophile. The ketone is gonna be the electrophile. And our shortcut tells me that I should lose this. And I'm looking for, sorry, I'm looking for Z, but since they are the same side, this is gonna be neither Z or E. Because then how do you prioritize here? You can't. Yeah. But where you have different groups on either side, you really have to specify. Alright, that's good. Are you still working on the second?
No, I think I got it.
Okay, this time this carbon is this carbon, you should say. And then you're looking for for E. So this ester must tilt to the right.
Got it.
If you tilt it to the left, you have a Z.
Okay. So this is the Z confirmation.
That's the
The
E.
alkyl. Oh, because of the lone pairs.
No, no. You have to follow the process of assigning E and Z. Show your hydrogen, cut the double bond. On the top, this priority 2, the carbon is priority 1. At the bottom, you see these are propyl, that's an ethyl. So this will be priority 1, this will be priority 2. They are opposite, that means E.
Um, but in order to know that it was the E confirmation, it had to be stable.
Oh, yeah. If that's what you meant, yes.
So is it stable because of the lone pairs that are on it?
No, even this one has lone pairs. It's stable because it has an electron withdrawing group. This one also here has a lone pair. It's
So
still a yellow.
Um, electron withdrawing.
Yeah, if you draw it out, you'll see that you can push these double bonds inwards. That's what makes it stabilized yielded. We're about to do mechanism to show you how we are always losing this part. So both of them have that part lost. Always lost. This one, remember, it was unstabilized. It's very important to know.
Okay.
Or note that. Note whether it's stabilized or unstabilized. Very important because that dictates your outcome. And that's how you're gonna get caught if you don't pay attention.
Okay. That's not too bad.
No. Okay, so let's do the mechanism. So for whichever, so if you're going for the Z, well, the mechanism is the same, only that you'll have to force it to either be a Z or E. Mechanism is always the same. You see how they're showing resonance stabilization here?
Yeah.
Yeah. They're not showing any rotation. They're just saying this thing is resonance stabilized. And whenever it's resonance stabilized, it tends to give you we call that the Horner Wadsworth Emmons Wyrick modification. It should give you an E. Uh, so you see how we've been using PPH3? Sometimes
Yeah.
it can be this, but it's the same thing. Both of them will give you E. Whether you have this part or PPH3.
Okay.
As the main guiding part of the molecule is the carbonyl electron drawing group that forces an E. So this one's called Horner Wadsworth Emmons because these three scientists came up with this reagent. So instead of PPH3, they put methoxy, and then a phosphor oxide. They just call it a phosphate ester, yeah. But still, you see there's resonance. Okay.
Yeah.
Yeah. So whether you have the PPH3 with the ester, or you have the POOME with the ester, go for the E. Let me show you something here, just to include that other reagent. It's not always MEO, sometimes it can be ETO, but you don't want to put a proper there, it will be too big. So this one most likely they will not give it to you as a double bond. The phosphorus there is just happy with what it has. So most likely this one not gonna be drawn in resonance structure. It's gonna be drawn plus minus.
Okay.
Most likely this is just how it's gonna be drawn. And in fact, the plus there is implied because phosphorus can take expanded. So there's no positive on the P. You will not see a double bond here like we've been doing with PPH3. That's all I'm saying.
Okay.
But
it's essentially the same
it
thing.
is the same thing. Just know you're losing that whole mess of the phosphorus.
Okay.
This time you're not losing it as PPH3 or you're losing it as a whole. Just say it's lost. And I can show you the mechanism later, but that one would be a stretch of a mechanism anyway. I know the mechanism that comes is either the PPH3 stabilized or unstabilized. So that will be the product. You're looking for the E. So let me draw the E. Sorry, I lost my touch.
So if I see this reagent, it always goes E.
It's supposed to go E. I'm thinking how I can do this. In this case, you cannot determine whether it's E or Z because one side has the same thing. You see that? So
Yeah.
this is neither E or Z. So I'll give you one more that can dictate things. This is the Honor whatever the name is, Emon's Wyrick reaction.
Okay.
Okay, so HWE reaction. So let's see if I have this and you're given the same thing. Let me make it smaller. Mm, So this carbon is this carbon. That's the most common mistake students do. They lose a carbon. This right here is supposed to be an E.
Okay.
Yeah, so I'll show you just one mechanism and then you will for this and then you find time as usual and practice. Only that you just force your result to either be an E or a Z.
Okay.
Um, Let me come to a new page. So we usually it depends on how far your professor want you to go. But the mechanism I'm about to show you is gonna be for this predicting the product.
Okay.
You can apply that to anything else. Okay, when you're ready, let me know.
I'm ready. I'm ready.
Are you ready?
Yeah.
Hello. Hello. Are you ready?
Yeah.
I can't hear you. What
Oh,
happened?
really?
Oh, now I hear you.
Yeah, I said I was sorry.
All right, so the very first step usually we do is SN2, and you are using this as a nucleophile. You know SN2, I don't want to go back there again. Organic one coming back to bite people. So make sure you know the number of carbons you have. Maybe I'll have to redraw this somewhat so that I have my carbon ready for attack. So imagine the lone pair attacking the bromine carbon and this falling out. Then you have PH3P, a bond, and then three carbons. One, two, three. One, two, three. The beer is gone.
Okay.
Immediately that happens, my friend, positive charge on phosphorus. Now you realize we don't have a negative charge. What do you think we should do next?
So we have to use that BULI thing, right?
The bully comes in and he does exactly that. He bullies.
Okay.
It's a butyl lithium, so I've shown the four carbons. That's the Bu part. Very strong base. It's a bully. How does he bully the molecule? He takes away the alpha hydrogen. One of these is gonna go. So step number one, like in electrophilic aromatic substitution, we were making electrophiles. Here, step number one is formation of the yelid. This is our yelid that can do resonances to give you the one with the double bond.
Okay.
So if you push this here, phosphorus can take more than an octet. You get the yelid nucleophiles for the next step.
So that like bullet thing
That
just
one,
puts lone pairs on it.
huh?
It just puts lone pairs on it.
Yeah, he becomes butane.
Okay.
He steals the hydrogen and becomes butane.
Okay. Got
Without it, no Wiric reaction, no chance, no yelid formed. So that step is done. So once you have your yelid, you bring it here. And this is how I survive with this next step. This is how I survive with the next step. I make sure my oxygen is aligned with my phosphorus. I don't know, it's P first, then pH3. So this thing is quite big. You basically have a phosphorus, and the phosphorus is bound to three phenyl rings,
it. Okay.
which is why we don't want to do this. We just do pH3 phenyl. pH is not the pH for acidity,
Mm-hmm.
it's a pH for phenyl.
Okay.
Now again, you don't want to forget the number of carbons. 1, 2, 3. So you have the yelid nucleophile or Y lead. And then you have the carbono electrophile. Remember, whatever we are doing for ketone, you can do for aldehyde.
Okay.
If this was master's or PhD, I'll also show you the Wiric reaction with esters and also nitriles. It keeps going.
I'm near the end. I have like 3 more weeks of work on.
And then there's another yelid I was trying to discover in my research, but it refused. But I've not given up.
You got this.
The reagent was not behaving. So I told myself, well, maybe Wiric will, and Onahimons also tried and it failed. It was an idea I had because my reaction was not working, so I was coming up with a new Wiric reagent, new yelid.
That's cool.
But again, if I would have discovered it, students 2 years down the line will have it in their textbook. One more problem to think about.
Literally. I don't have to think about Orgo until I take my MCAT.
Hey. That's one way of saying I won't miss you, Moses. I won't miss you.
No, I'll have you for biochem and then.
Oh, okay. We are still here.
Yeah, for Gen Chem and then for Orgo
MCAT.
again.
Yeah.
All for my MCAT prep.
We are still here. So start from the carbono as the nucleophile. Well, I think it doesn't matter. Just like Dios Alda, I showed you that it doesn't matter where you start, as long as you form what we call the oxophosphate intermediate. So realistically, because yelid is a nucleophile, let it attack the partially positive carbon. And then this bond will go down here. Once you draw the arrows, nobody will know which arrow started.
Oh, okay, so it comes with a double bond.
Yeah.
That's double bond, double bond.
Correct.
And then double bond phosphorus.
Correct. So you're going to get a very strained 4-membered ring. You know from organic 4-membered rings are 4-membered rings are not stable. And then here we collapse it. Let me see if they spelled it right, but it's oxophosphate intermediate. If I'm not wrong, that's how I put it in my website. Let's see what you have in your notes.
A weird thing.
Yeah. I hope they gave it a name. Most of these authors don't give it the proper name. Yeah, oxaphosphatane. Oxaphosphatane. It's me who's misspelled it this time around. Oxaphosphatane. A and E. So A here, E here, and there's no I.
These are big words.
Yeah, this is a language. Organic chemistry is a language. You don't learn the language, you're cooked.
Yeah, I agree with that completely.
Yeah. Phosphatane.
Hopefully this stuff is stuck in my brain enough to where when my MCAT does roll around, I remember all of it.
Yeah, if you are good in organic chemistry and you don't forget it, the only worry you'll have on is general. The pH stuff and acid and base is the biggest part of MCAT.
I'm not gonna
Buffers. Hmm?
You like don't get a calculator on that.
Yeah, they usually give you, if it's concentration, they give you concentration in terms of 1, 0.1, and therefore you can memorize how to do logs in the powers.
Yeah, I'm not good at mental math like that at all.
You have no choice. I'll tell you that. So let's collapse this. Remember, I always tell you that this part is always lost.
Yeah.
So it's like you're doing a retro Diels Alder. So it's simple. You can collapse it from whichever direction, but either way, you will end up with your alkene. Now, what I want you to make sure is that you're getting your Z.
Okay. That's
That
what I'm most worried about.
Yeah, that forces you to put the ethyl groups on the same side because should give you a Z alkene, which is what I told you. The mechanism is the same. It's just the last step that you have to be keen on how you're going to draw your alkene, if it's at Z or E, if it's stabilized or unstabilized yield.
That one's fun.
Yeah. So that is that. The other mechanism, they did not give it to you because they know why.
It's too hard.
Yeah, I don't think it's something we want to prioritize now until later. We've talked enough about immediate reaction.
Okay.
So remember the byproduct is this. Let me text these kids. They need to go shower. If I don't tell them to shower, they take advantage that their mom is gone to work. Hey Joe, make sure you shower, okay?
Yes.
Tell Gloria, shower before 7.
You already showered.
Okay, close the door. Okay, so that is the mechanism. I hope that is clear.
Except practice.
Yeah, and you'll see it is all that they're showing you here, nothing new. Just practice.
I'd
Now,
rather forego than my calc test, so, you know.
ah,
I have a calc test the day before my orgo exam, and I'd rather do this than calc. I hate that class.
you had calc today?
No, I didn't, but I have it tomorrow, but I'm not gonna go. So, like, I need to use them, so it's my only class of the day, so I won't have to go to school at all.
Oh, okay,
I'm gonna stay home to study.
okay.
Hate that class.
Your exam is when?
The 14th, and then my orgo exam the 15th.
Okay. So where did we stop after? We've done the review. Oh, no. Before this, let me quiz you something. Quiz you on something because I know this is how they can test you. Also, I like exploring both ways or always because your professors are wild geese you can't predict. So I need the starting material for that. And I need the starting material.
How do I go backwards?
Yes, that's the essence of this question. Who is the carbonyl? Who is the yelid? If you need help, you just let me know. That's why I'm here.
I think I get it.
Don't strain. I'll give you chat time. You do one, we review. You do the next, we review. And it's always good when you're doing such questions.
Okay. I think I got the first one.
Give the title so when you're reviewing, you know you're looking at which reaction. You got the first one. So what I'll do, I'll cut it. And you can have two ways to this product. There are two ways. So I can make my yelid the top part.
Okay.
And then the bottom part, I can make him my carbonyl. See, that's an aldehyde.
Okay.
Alternatively, I can make the bottom part my yield.
That's what I did.
Okay, and then I know that's why I left. I started from the bottom. I know most people will do this top part, and then I'll make that the carbonyl. So there are two ways to do it.
Okay.
See, it's doable. It's just that there's several ways we can quiz you.
Yeah. I
So
was really like worried about this chapter, and then I studied it a lot today,
good.
and it wasn't bad. Like I was like, okay,
I
I need
know
to.
you're good at predicting products. That I know, and I know you give yourself good time to practice mechanism. So I have no issues with that. It's just a lot, but as you get closer to the exam, you'll feel more comfortable as you go. I know it's a
Yeah.
lot. That I know.
I feel
Don't
like I never
don't
feel.
postpone anything. Don't procrastinate. And I told you, do
Okay.
targeted studying. Don't skip pages. Finish
Okay.
one thing at a time.
Yeah, that's what I did today. I like wrote down like, okay, do this mechanism, then
Yeah.
finish all that material, go to the next mechanism,
Yes,
and then
exactly. Yeah.
everything started to click at the end. I did the next one. Yeah, I did that.
Okay, so this side I switch. It's just like the Grignard that you don't like. You
No,
can
I
make
like.
the you like it? Okay. You can make your Grignard by splitting. You can predict the starting materials in several ways. So it's the same thing here. And I bet both cases can come predict product or predict reactants or both. Both of them. Usually for me I test both. If I say one predict product, the other one I'll say predict reactants. Or combine even with a mechanism.
Okay.
So for this one, I'll split it. We are always splitting the carbon anyway. There's a hydrogen here, so this has to be an aldehyde. These ones were ketones. The green part. Now, you see how this is drawn as an E?
Mm-hmm.
It's giving me a clue that I have a stabilized yield.
Okay.
And this was that's neither Z or E because of the ring. The ring can be cut into equal half. This one, I mistakenly drew it as an E, but it's maybe the minor product of it. It's supposed to be a Z for A.
Okay.
So that's how you do it, and you realize for C there's no other way.
Mm-hmm.
Yeah, you cannot draw the other way of making it. It's just only one way.
Got it.
You are restricted by the stabilized yield.
I feel like I'm just afraid of this easy thing because I always mess that up.
Yeah, you can count your carbons to make sure that you're good. And I think I forgot something here, the ppH3, because that's always lost. This one, always lost. Okay, we talked about the reverse and going forward of PADPID. We did a lot. We talked about that. We talked about with Kishna. Bear Village, I believe that's where we were. And then we talked about this maze. IR, you are to revisit that, and that was the end.
Scared of the IR.
Yeah, I know because last time he brought something weird. That's why.
Yeah.
The NMR. Are you good with the recitation part?
Yeah, I've been working through it. That's what I do at the end of each like mechanism practice that I've been doing. I've been doing the recitation problems, and so far I'm fine with everything.
Okay, yeah, let me just peep in there and see. So you see all this, you can use the shortcut.
Yeah. Okay.
I showed you the shortcut last time before we left.
Yeah.
Yeah, those mechanisms are good using the PADPID. You probably got that right. Making the imine ADP. Is it
Yeah.
ADP PED
I think it
or
was.
ADP for the imine? Okay,
It
so
was APD PED.
yeah, for this one you get the iminium salt and then pretend you're removing a hydrogen from the shoulders to get the enamine because these are secondary amine.
Okay.
That's a secondary amine. Also, you're going for enamine.
Okay.
Did you get enamines for A and B?
Yeah.
Good. And this is going the reverse. This is usually a challenge to students, but I usually tell myself the carbon of the acetal is gonna be the carbonyl. I just put a cut off here, here, and put the carbonyl here. The carbonyl is actually here, not down here. I hope you
Okay.
realize it's a meta now.
So it goes in between the two
Yeah,
O's.
then this would be OHOH. Like here, this is OHOH, carbonyl goes here. This will be OHOH, carbonyl goes there.
Okay.
Enamine, bring it back to an iminium salt, carry it, you'll see the ketone. Where the
Okay.
nitrogen is, that's where the carbonyl is. Where the nitrogen is for imine, that's where the carbonyl is.
Okay.
I hope those ones were good for you. And then the synthesis, were you good with them?
I haven't gotten there yet.
Okay, let's talk about this. Where did you get? How far did you get?
I didn't get to the hydrolysis stuff yet.
Okay, then we got that back.
Those were like the last two things.
You've not done 19.6?
No.
Okay, it's
I can do
fine.
everything else though.
It's fine. Don't stress. The thing is, I keep on telling you, and that's the best ever advice for this chapter. Do a targeted study. You skip around, you're dead meat.
Yeah.
Yeah, target it. That's my lecture I was recording. You target it and perfect it. When you feel comfortable, then you go to the next. If you're not
Yeah, that's what I'm
comfortable
gonna do.
yet, yeah, if you're not comfortable yet, stay there. It's not a waste of time. Stay there. Because then, if a synthesis problem comes and you something that you gave up on, there's no way you're
Yeah.
finishing that synthesis.
No.
Yeah. Okay, so I'll give you the general. I know you love that. So if someone gives me, let's do this. If someone gives me an acetyl group, whatever that OR is, and of course I told you this is gonna be reversible. I'm wondering why they're using one-way arrow. That's a felony. I would cut out this, and the carbon that had those two alcohols will go. So I'll get that, and then I'll get my ROH. So that's the general idea. I know you're gonna go the opposite. I don't know if it's PED, PAD, whatever the mechanism we said is for the reverse of acetal formation. That's what you're going to follow. Now,
The removal of oxygens.
yeah. So this carbon right here is my interest. That's the carbon of my interest. It doesn't matter the number of carbons on the house, on the head of this ring. We talked about that these carbons can be 2, 3, 4, whatever it is, it doesn't matter. But my shortcut tells me that I cut here. That's what my shortcut tells me. I love shortcuts. And the carbon takes a carbonyl. The other part will become OH. Or stretch it, the right way to draw it. Not hard.
So basically just where you cut becomes a carbonyl.
Correct.
Okay.
And that is the acetylcarbon or even the hemiacetal carbon, because those ones can also be hydrolyzed.
So you just cut by the oxygens, and then where that cut was done, you put a carbonyl.
Correct.
Okay.
You will do the same thing for B or whichever question you're gonna get in the test. Identify my carbon of interest. Usually it's the carbon carrying the two oxygens. So this is my carbon of interest. He has two implied hydrogens. I know that because I only see two lines, two bonds to the oxygens. That carbon is of my interest. So in presence of an dilute acid, I know that my carbonyl will be on that carbon and the other ones becomes OH.
Okay.
I'll give you two shortcuts for the
Okay.
imine hydrolysis. This is how you save exam time. You finish it ahead of time and you start reviewing your work. Like you said, you think you make mistakes in this simple predict product stuff. So whenever you use such shortcuts, it gives you time to review your work. When you just quickly predict and you go back to check your carbons, check your number of elements, and reread the question to make sure you did not misunderstand the problem. So again, I'll show that carbon. That carbon is of my interest, and that's the one that's gonna take the carbonyl. And then the other part, nitrogen, is gonna be an amine. But because we are in acidic medium, there's no base given here. You don't want it to stay with the lone pair. That's a catch.
Okay.
We'll do a lot of this in biochemistry where we call it isoelectronic point, especially for amino acids. Oh, they are coming. It's a lot there to do. We'll be careful on charges. What were you saying?
So did you move the double bond, or are you just showing me like how you work with amines, or are we doing number or question B?
Yeah, we're on B&D, but I have to give you the general idea.
Okay, because I was gonna say I was like, wait, that's not what I did. Okay.
This general.
Okay.
because I told you, I don't know when is the first time I saw your beautiful face. I told you that organic chemistry is not for memorization.
Mm-hmm.
You try that, you go bananas.
Yeah.
It's understanding and application mostly. Well, it looks like application is more than understanding, but you can't apply if you did not understand.
Yeah.
Yeah, so you want to know the general idea, and then now you practice even more. Um, anyway, you get what I mean. So this is an enamine. How do I know it's an enamine? For example, here I have the alkene. Up here I have the amine. So you put the two together in amine. So you put the in and amine together. So enamine.
Okay.
Now the way I do this is I usually take this back to the iminium salt. However, if you just want to cut out the nitrogen, it's still fine. But I like keeping the idea that this enamine was formed from an iminium salt. So I usually do a retro kind of thing. Then once I have my double bond, I can definitely see, like we did up here for imine,
Mm-hmm.
just chop that off.
Okay.
So our carbon of interest is always the carbon carrying the nitrogen or the oxygens. You do that, it becomes easier for you to remember because there are a million molecules that can be tested here. Again, you're in acidic condition, so this is gonna be protonated maximally. We are doing this in acidic conditions. Now, if you feel that you're advanced, then just go ahead and chop off the single bond in the enamine and put a double bond O.
Okay.
So doing that, you see if I can, for D, if I chop here, if I feel advanced and comfortable, I'll just put the carbonyl there.
Oh, that's it?
Yeah, and then just make sure my nitrogen is having 4 lines. Otherwise, you can make the iminium salt in your shortcut and then know that is hydrolyzed just like you hydrolyze the imine. Because the imine has to form the iminium salt because it's before it is hydrolyzed anyway. So here I'll do the same thing. Chop off the nitrogen, put a double bond. The nitrogen itself is gonna need 4 lines. I only have one line to the CH3, which means I just bring up the extra hydrogens. Very easy to do. Well, after practice.
Yeah, that's how it would go.
Yeah, you'll be sitting there drinking water. You stand up, you stretch a little bit. I used to go running. I go run. Well, I'm Kenyan. I have no choice. I go run, then I come back. I do some more. I go run.
What I've learned is like overdoing it sometimes like is just not helpful.
No, the moment you feel like you're doing this, you're started to do so many stupid mistakes. It's
Mm-hmm.
telling you stand up and go.
Yeah, that's what
Stop.
I've been doing. Where I just go to bed. Like now,
Yeah, yeah. Or just go to bed. Take a nap a little bit. Or distract
you know, like
yourself.
the
Rest.
exam I did the best on, I studied the least for.
Yeah.
So clearly, not the least. Like I still studied a lot, but I would have wanted to study like maybe 12 more hours,
Yeah.
and I had that time. Um, but I did the best on it. So clearly, taking time to like recover and things like that are important.
Yeah. Don't strain. And focus studying helps. Because then it gives you a feeling of fulfillment. that you achieved something because you studied not much concepts, but and then you mastered it. Then you feel like, there's progress. But if you decide to read 10, 15 pages of concepts, you
Yeah, that's the
barely
worst feeling
learned.
ever. When you like feel like you've spent the whole day and you haven't learned anything. That's the worst feeling ever.
Yeah. But if you can target fewer things and master them, you have that feeling that you mastered it. And also that's true because if anyone gives you a question on that on those few concepts, you get them right most likely.
Yes, praying for another A on this one. It's my last exam before my final, so
Yeah. You are almost there. So you
crazy.
then you're going to
But
have a summer to yourself. Are you taking summer classes?
no, I was gonna take physics over the summer, and then everybody told me not to. So I'm
Be-
not. I'm just gonna
because
work
it's a
all summer.
lot.
Yeah, and I'd like to not like start school on a bad foot. You know what I mean? Like I don't want to be burnt out before I even start my semester.
Yeah.
So I was like, okay, I'll just work, enjoy myself, because like with medical school, there's so many other things you need to do. So
Yeah, internships, hours, volunteering.
yeah, so I'd rather do that. So I'm gonna work again this summer, which will be nice, and then I'll have some money.
You work in the hospital?
I work at an occupational hand therapy office.
Occupation health therapy. Okay.
Yeah. So I get a lot more like one-on-one interactions with patients, and I really like it. I've done it
Yeah.
for 2 summers.
Let's see. Here comes the fun part. Yay! Yay!
Synthesis, I
Finally!
was terrified.
Finally! Yay!
You learn the most from synthesis. Like if I like you don't even need to do major products questions. Like if you just do synthesis, you're fine.
Yeah, that's true. If you are able to do synthesis, that means predict products, you're fine.
Yeah.
So
If you're able to do the
propose
mechanism, you're
the
fine.
synthesis of the following. So the first A. Well, let me hear what you have to say about A. Look at it, smile, and tell me something.
Well, we have an extra carbon that is also an alkene.
Thank you. So we draw that out. Then, well, that's the only one. Okay. So how do we get there?
I really am not sure.
You want me to walk you through it?
Yes, please.
Organic ones told us that anytime you are doing, well, I met you after you've already done chapter one, exam one of organic one, but alkanes are not reactive. So for them to react, you have to do radical.
Okay.
And usually for radical, it's not NBS for alkane. For alkenes and benzylic carbons, it will be NBS.
Okay.
Okay, so Br2 heat, we know it's gonna go to the more substituted carbon because of the tertiary radical intermediate. It's not gonna go where that CH2 is, where that double bond is.
Okay.
And then from here, I'll do what we call a bimolecular elimination. I'll use the no, if I use chicken foot, it's gonna go outside. So I don't want the chicken foot. I want Z7. So I'll use a smaller base like NH2
Okay.
or Naomi. The SN2 cannot happen because the bromine is on the tertiary. So I'm going to get the Zaitsev. Purely organic one, unfortunately.
Okay.
I'm thinking of doing a Vedic because it's what we've learned recently that gives us double bond.
Okay.
So I'll need OH on that carbon. I need an OH on that carbon. So I need OH here. That reagent, it was one of your favorite. It was two steps. Which one is that? Antimicrobial.
NaOH? No?
That's the NaOH is just part of the second. You cannot add OH directly to a double bond. Let me give you a hint of the second step. You have NaOH, and of course, because it's antimicrobial peroxide. What is the first step?
Why am I forgetting this?
I don't know why you're forgetting this. You drank a lot of coffee. That's why.
I haven't drank any coffee.
You don't drink coffee now. Let me guess again. I can't guess then. Don't know why you forgot. But it's BH3. Hydroboration.
Oh, and I like that one too.
Yeah. So it puts it antimicrobial. And now this one can be oxidized to something we want. By PCC or Jones, definitely that's gonna give you a carbonyl.
This is secondary, so you want to do a ketone. Okay.
Yeah, and then you're just gonna bring up your yield. I'm trying to see how I'm gonna write it so it makes sense. Like this. And then we know our shortcut already. And we are done. CH2 is added. Now let me put names. Weedig with unstabilized, well, that's neither Z or E. We name that. This is radical.
Okay.
Very doable. That said, organic one is needed. Heavily needed.
Okay.
B.
It's gonna be weird getting used to all of these reactions again.
Yeah, I know you'll have to review them by the time you're taking your test.
But at least it's like review for now because this is all stuff I also need for my final. You know what I mean?
Oh
Like
yeah, it's
it goes
comprehensive.
back to the beginning and then comes back.
Yeah,
So I'm happy it's coming up now, not later.
yeah. Yeah, it's good that we're touching on this, and you'll see another touch here on organic one. We call that a terminal alkyne. Oh, am I
Yeah.
too fast for you? Should I wait?
No, no, no. I'm writing the same thing.
See, I'm gonna bring this down a little bit.
I like do not remember any of these reagents. This is not good.
They'll come by. They'll come by. So at least you can tell me what you see in the product. Was carbons added or not?
2.12. We got an extra carbon and an OH. And we get rid of the triple bond. So we go from alkyne to alkane and get an alcohol with an extra carbon.
Is an extra carbon. So that tells you you have to do what?
Right here. Can we do a grignard?
Yeah, you can do grignard, but how do you do a grignard on that?
We need to get I forgot how you reduce a triple bond to a double bond.
You can do
Can you do
Lindlas or ammonia, sodium and ammonia.
that? Okay. think we should do? I'm sad.
I'm thinking I have two ways I can do this, which is a good thing that I have multiple ways to do it. I'm thinking of the best. What I'll do, I don't know if you remember reactions on epoxidation,
Yeah, the R
the peroxide.
RCO3H, right? Is that it?
Yeah, but if I do that, the methyl group has to come in as a in basic conditions. It's not gonna add on the more substituted, so that is out. Mm, I'm trying to see if I can use hydroboration again because that OH is outside. Well, let's start somewhere. One, no, one, two, one, two. This chapter is on aldehydes and ketones.
Yeah, so I'm like really confused.
Ah, no, I see. I see what they did. It's a combination of two reactions that you've learned.
Of like two new ones.
Yeah,
Um,
actually, you can use one new one or you can do two new ones.
I think
Either way,
you get the two OHs.
you don't want to get two OHs there.
No? Okay.
You're thinking too much. So let's
I
take the ring to be a pH and no, let's just flow. Let's take the ring to be a pH and we're going to make it a double bond as you suggested. And then,
what's the reagent for that?
huh?
What's the reagent to do that? Because I completely forgot.
Oh, to stop here, you can do either Lindlas because it's neither E or Z.
What it
So
is.
you can do Lindlas or you can do sodium and ammonia.
Okay.
So if I do Lindlas, I stop here. That's neither E or Z. And then I'm going to make this thermodynamic OH, more substituted OH. And to do that Markovnikov addition, I can do oxymercuration or I can say H3O plus. It doesn't matter. It's Markovnikov hydration. Organic one.
Okay.
And then after the Markov hydration, I can do PCC or Jones. No, I don't want to do Jones because that would make it a carboxylic acid. Remember benzylic carbon
Yeah.
oxidation? So PCC is the best choice.
Is it like it looks like ketone, right?
Yeah, so it gives us a ketone and then I can introduce my yelid, the same yelid we did. This was not an easy one, I'll tell you that.
Yeah.
Okay,
This is like
so
everyone in my
yeah, so it gives you a yelid with your CH2 on there, and then from there you can finish it off with hydroboration, which is what I was thinking. Where can I use it?
the BH3 thing again.
The BH3, yeah. The OH goes on the least substituted side, yeah. That is the cheapest, most straightforward way of doing this. There's another way you can do this by reduction. Okay, well, we also did reduction in the beginning, so that's good. So we added an extra carbon by Wittig. Looks like in the next test, if you want to add an extra carbon, tell yourself you have a Wittig
Okay, so you can use to add an additional carbon. You can use a Grignard, a Wittig.
or a
Is there any
CN.
or a CN? Okay.
Yeah.
Okay. My brain hurts.
Sorry,
It's okay.
this organic chemistry can be very intimidating, but I like it because it's kind of a puzzle and I like to solve puzzles. But now for a grade, you will not like it.
It's definitely cool though. Like it's my favorite class I've ever taken. But
It just takes a little too much. So let's look
yeah.
at C. C, let's see. I think we did something in regard to C. You see how we went up to here for C.
Mm-hmm.
You go the same way to this point.
Okay.
Same steps. Now, when you get there, you do a green yard because we have,
One extra carbon.
yeah, we have this CH3 that you can bring up as a green yard, like you said,
Okay.
and
Give you the alcohol as well.
there will be an O minus with your CH3, which is why we add H2O to give us OH and the CH3.
Okay.
That is if you remember the four organic one reactions: radical halogenation, E2, hydroboration, and PCC oxidation.
Okay. I'll remember them soon.
Yeah,
The next one looks scary because you have to do a ring opening.
I've not checked it yet. Yeah, that's a ring opening reaction, and it seems to me like we are doing a Bayer villager, then we open it up.
Okay.
Let's bring it down here so we can see it. Okay, so D. You ready?
Yes, I am.
This is the kind of molecules that I prefer doing a retro than forward.
Okay.
However, let me think. We have a ketone.
Yeah.
Mm.
This one is scary. I don't like this one.
Ozonolysis of an alkene.
Okay.
That will not work. Well, it might. Ozonolysis of alkene might. Let me see. No, it will not work. Will it?
I want to just
Ketone.
split them into two.
How do you just split it into two? You have a key. Ah, okay. I see, I see. But that's a protecting group. If I get a hemiacetal, how do I get a hemiacetal group? Did we add any carbons? It seemed like we added a carbon.
Yeah, there's one, or there's two extra No, there's one extra
Just
carbon.
one. Okay. That gave me the hint. So as always, alkanes are not reactive. We know where we should start.
So the bromination thing.
Yeah. HB or heat. And usually when this happens, we most likely go in E2. And with my E2, I want it to go Zaitsev. So I can do ozonolysis as I taught before. That's what you meant by ring opening.
Okay.
It's usually O3. I don't know which version you used, if it's DMS or zinc HCl. Dimethyl sulfide or zinc HCl would give you an aldehyde. Looks like someone needs a protecting group.
Oh no. Why is so hard. I'll get used to
Can
it.
we put a methyl group before? Put a methyl group before splitting. That would be better. Like we did before. Um, let's put our carbonyl there and see. I'm trying to avoid protection. We only protect when we are desperate.
Okay.
Yeah, so put OH here. Do our PCC. It's gonna give us a carbonyl. Think. Mm, basically, we are doing C. We are making C.
Okay.
Trying to stay consistent here. Then another organic one. This is E1, dehydration. You will give me Z-cell. And then, yeah, this would be helpful to do because I don't need to protect. Then we can do ozonolysis.
And ozonolysis is the thing that will open up the ring.
Correct.
Okay.
Now if I count, I have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So we have this and that. And here we can do one equivalent of another Grignard. So only one ketone will react.
Okay.
Hopefully. It's not telling both of them can react, but at least if you give it a very minimal amount, only one will react. And that CH3 will go here. That is a bad one. I guess this one will have so many blanks in the test.
Yeah, I hope he doesn't do this. I don't like it.
This is very cruel. Not a joke.
I'm scared because we still have to do the whole carboxylic acid chapter.
I don't think you'll finish the whole thing.
Yeah, we only have 3 lectures until the
You are done with this chapter,
With this chapter, yeah.
and then you're just left with the carboxylic acid one. It's not gonna get to the amines.
That's the next exam. Like that like goes into the final. So there's some stuff that we haven't learned yet that will be on the final. Which stinks, but
He has to get to the amines because that's the bridge. Carboxylic acids, aldehydes, and ketones, and alcohols are the bridge to biochemistry.
okay. I know, like, we have a lab on amines, and he said he wanted to, like, be in line with lab. So, I don't know. I don't know if he said chapter 22 we might not get
He
to.
might rush this thing so bad.
Yeah, probably. My final, this is the first final that I have. It's on the first day, which stinks. But
Then you'll be free.
yeah. This is my only cumulative final, so it's the only thing I have to worry about.
Yeah. Anyway, you can see I try to use simple steps that you have
Okay.
done before.
Just a
Get,
lot.
yeah, but there's a lot because you have to be very creative.
Yeah, for sure. Ugh, my head hurts. And then tomorrow, can we work on? I'm gonna work on this, and if I have any questions, I'll like give them to you. And then should we do the carboxylic acid stuff tomorrow, just to get
Yeah.
ahead? There's a lecture on that till Wednesday.
Yeah. All right, I'll see you tomorrow.
Thank you so much. I'll see you tomorrow.
Good night.
Good night. Bye.
Bye.